All right, here we are. Day 9, review Q5. All right, I believe there's 10 questions in this one. I went ahead and worked a couple of them out, and so we can just talk through them quickly. Okay, the table below shows the times taken by two marathoners running a 26-mile marathon to complete the 4 legs each, 6.5 miles long, of the race. Now, actual marathons are 26.2 miles. Well, in this question, there's a 26-mile race. Okay, each leg was 6.5 miles long, so I wrote that here just so I know the distance was always the same for each leg. In a later question, that is not the case. All right. The average speed of runner 1 over the first leg of the race is most similar to the average speed of runner 2 over which leg of the race? Since the distance are all the same, all I have to do is consider the time, right? Because speed equals distance divided by time. So if my distance is always the same, all I have to do is look at the time. All right, 38 minutes for the first leg, first runner. Runner 2 was closest to that on the last leg of the race, okay? So the answer is going to be the fourth leg. All right, there we go. Question number 2. Same setup, same table, different question. All right, here we go. Again, all the legs are the same length. In completing the 26-mile race, runner 1 was faster than runner 2 by a time period closest to. Well, again, you can either add all these up across, right, and add all those up across and take the difference, or you can take the difference of each one and add up the sum of the differences. Okay. Now, if in some case, like these are positive, right? If there was like one where it was negative, you would need to take that into account, right? If somewhere in the race runner 2 ran a faster leg than runner 1, you would need to subtract here instead of making these all positives, right? Anyway, just be careful. Think it through. All right, 48 minus 38 is 10. 52 minus 40 is 12. 50 minus 42 is 8. And 45 minus 38 is 7. I add those four numbers together, and I get 37 minutes. Okay? 37 minutes. And let's do dimensional analysis. 1 hour over 60 minutes. We'll divide. And we should get 0.617. All right, hours. That is closer to half an hour than it is to 1 hour. So that's your answer. All right, great. Okay, use the information provided to answer questions 22 and 23. The graph below shows the speed of an object over a 40-second period. Okay, 10 seconds, 20 seconds, 30 seconds, 40 seconds. Okay, we started at 10, not at 0, so just be aware. All right, over which of the following 10-second windows of the 40-second period did the object's acceleration have the smallest magnitude? Okay, right here his velocity is constant, so he has a 0 acceleration, right? So here his acceleration equals 0. So 10 to 20-second window is going to be the smallest, okay? Now these are actually negative accelerations, all right? But there's still an acceleration, okay? So there you have it. All right, that's the answer to question number 3. Question number 4, same graph, different question. Which of the following calculations give the object speed at the start of the 40-second period in kilometers per minute? Kilometers per minute, okay? At the start of the 40-second period, he's sitting here at 30 meters per second. So let's start with that. 30 meters per second, right? And I like to write them on 2 lines, kind of like this, all right? Now I want to go to kilometers per hour. I'm going to change my meters to kilometers first. 1,000 meters makes 1 kilometer. All right, my meters cancel out. Now I want to go from seconds to minutes. 60 seconds over 1 minute. All right, and that'll give me, well, actually, we're not actually really finding the number. All right, we're just making unit conversions and figuring out which one of these represents that set of unit conversions. So we need 30 times 60 divided by 1,000. 30 times 60 divided by 1,000 right there. That's the answer. All right. Now remember, start with meters per second, meters over seconds, right? Meters per second. The unit on the bottom, to get rid of it, you need to add, you need to put the unit on the top in your unit conversion, all right? Make sure you get 60 seconds over a minute, not 60 minutes over 1 second. I see people do that a lot, actually, okay? Also, make sure you get 1,000 meters on the bottom because the meter is on top. Meter has to go to the bottom, right? You cancel top to bottom. You don't cancel side to side. So make sure you write them the correct way. Again, there's a review for these things in your notes. If you don't remember how to do this, go back and check it out. All right, question number 5. Force is measured in newtons. Force is measured in newtons. A newton is equivalent to which of the following units? Well, force is equal to mass times acceleration, and that is kilograms for mass, and acceleration is measured in meters per second squared. Okay, so that is what a newton is equal to. It's actually a kilogram meter per second squared. Okay, so kilogram meter per second squared is A. All right, it's not kilograms squared. It's not meters per second squared. The whole thing isn't squared. Okay, like that. And that's certainly wrong. Okay, that's the right answer. Alrighty. Question number 6. The table below shows the times taken by 2 runners to complete 3 legs of a 12-mile cross-country race. Okay, I made this question up based on the other one. All right, in this case, the first leg was 3 miles, 3.0 miles. Second leg was 5 miles. Okay, and the third leg was 4 miles. Okay, so these legs are not the same length. It's very important. Over which leg of the race did runner 1 maintain the fastest average speed? Okay, there's 2 different ways to do this. Typically, speed is equal to distance divided by time. But if you're a runner, you often keep track of time divided by distance as a way of measuring your speed, right? You might say, well, it took me so many minutes to run 1 mile. So you could really do it this way, or you could do it as miles per minute. All right? If you do it this way, you want the lowest number for the fastest speed, right? A 6-minute mile is faster than an 8-minute mile. If you do it this way, you want the greatest number, okay? So be aware of that, all right? So let's go ahead and do it this way, miles per minute. So 3 over 16, we're looking at runner 1. This is going to be 3/16. This is going to be 5/26. This will be 4 over 22. All right, get our calculator to compare those numbers. 3 divided by 16 is equal, oops, hit 33. 3 divided by 16 equals 1 point, I have trouble with my pencil here, 0.1875. All right, 5 divided by 26 is 0.1923, blah, blah, blah. Okay, and 4 divided by 22, 0.181. All right, so let's see, the fastest average speed would be the highest number because we're looking at miles per minute, all right? So that's my fastest. Okay? All righty. Yep, so it's leg 2. All right, there's my answer. Okay, let's roll on. Okay, so same race, right? 3-mile leg, 5-mile leg, 4-mile leg, right? 3 miles, 5 miles, 4 miles. All right, in completing the 12-mile race, runner 1 was faster than runner 2 by a time period closest to, again, all we have to do is add up the differences, right, and we'll get the answer. Let's go across instead, just for fun. So we're going to do 16 plus 26 plus 22. And that's going to be 64 minutes. Okay. And then I'm going to add up these. 19 plus 29 plus 26 equals 74. Oh. And now I'm going to subtract, right? The difference was 10 minutes. Now, we need to convert to hours because those are our choices. All right, 10 minutes, 1 hour over 60 minutes. We can divide those, and it's going to be 0.17 hours, right? Or 1.67 hours. So that's closest to this, all right? It's 0.167. It's a little closer to 0.15 than it is to 2. All right, so that's your answer. Okay. All right, last time, you could also get the same answer by subtracting, right? That'd be 3 minutes, 3 minutes, and 4 minutes, right? Difference. You add those up, you'd get 10. You get the same answer either way. All right, here's this lovely little graph, and we have a question about it on the next page. So let's see what I can do here. All right. In the above graph, what was the object's acceleration during the time window from 3 seconds to 7 seconds? Okay, so we need to look from 3 seconds to 7 seconds. And then I said, please note that all the acceleration values are negative for the scenario. All right, the object is slowing down, right? So you're going from here, right, to there. So let's calculate his acceleration. Well, acceleration is equal to the change in velocity over the change in time, all right? Or you can say final velocity minus the initial velocity divided by the final time minus the initial time. Okay, these are I's, these are F's. All right, so let's plug in values to this equation. Final velocity would be 0 meters per second. All right, and these should be in parentheses, I suppose. Okay, and there it was 6 meters per second. right? Over the time from 7 seconds minus 3 seconds. Okay, now when you add or subtract numbers of the same unit, you don't do anything to the units. The units stay the same. So this is -6 meters per second over 4 seconds, right? So -6 over 4 is -1.5. Now my units become meters per second, or meters per second squared, okay? That's the answer you need to find. All right, so back on this page, look, there is indeed the answer choice that we need. Boom. All right. Question number 9. Here's the same graph. Which of the following calculations give this object speed at the time t equals 2 seconds in kilometers per hour? So we look for a time at t equals 2 seconds. There's 2 seconds. Scroll straight up, and there's obviously, we're moving at 6 meters per second. All right, let's do our unit converter. 6 meters per second, and we want kilometers per hour. So 1,000 meters is 1 kilometer. All right, meters cancel out. And now we need to change seconds to hours. So we got 60 seconds is 1 minute, and 60 minutes is 1 hour. All right, my minutes cancel, my seconds cancel, I got kilometers per hour, my answer. Now the choices I have down here have 3,600. Well, 60 times 60 is 3,600. Okay, so I want 6 times 3,600 divided by 1,000. It's C. All right. I hope you can do unit conversions. They're going to be important. Moving on. Okay, last question on this one. Question number 10. Potential energy is calculated as mass times gravity times height, right? PE equals mgh. Which of the following is the correct set of units for potential energy? Well, if you don't know this already, potential energy is measured in joules, okay? Potential energy, kinetic energy, mechanical energy, they're all measured in joules. So is work. All right, but if you're not sure, kilograms for mass, meters per second squared for gravity, and meters for height. So it's a kilogram meters squared per second squared. All right, looks like this one right down here, D. Okay. All right, yeah, or multiply these together. Kilograms, meters squared per second squared can be written as kilograms as meters per second, quantity squared. Okay. All right, there you have it.